earliest land and animals right here, and the period is the Silurian period. Easy breezy. That's it. Silurian period, short and simple, no questions asked. Boom, boom, boom. Question number 6. Let's move ahead. Question number 6 says the map below shows the present day position of the continent. Point A and D represents location on the Earth's surface. The location of the la 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 la. Okay. And the main question says, which letter best represents the inferred position of New York State? Inferred position. All right. Inferred position of New York State region on Earth at the end of the Devonian period. Okay. So those are the key things that stands to me in that sentence. Inferred position, which means where was New York thought to have been during the Devonian period. So once I see the Devonian period there, I know that of course this is ESRT. Once again, pages 8 and 9, or 9 and 8, whichever way you choose to put it. And of course, the stuff that is being discussed here is not something that is alive. It is a rock, or it is a state, or a portion of the Earth. So definitely, I will be looking at the other 2 columns that I discussed moments ago. So I will be looking at either geologic events or the land mass. So since talking about land mass, a part of the continent, then I should be looking at the last one, which is the inferred position of land masses. And we are looking at where New York was during the Devonian period. So I'm going to scroll all the way down to the Devonian period. Devonian period right here. I think I should take all these out first. So Devonian period is right here. And I'm going to go all the way to look at the position of New York. So if you see New York here is right around somewhere around the equator. So if the equator is here, you can see that New York is right there. Remember, it is where we live, the North America, that is shaded completely in black for us, so that it's easy for us to recognize. So that's North America for you. So looking at North America and looking at the position of the equator, I can tell that New York City was somewhere around the equator. So going back to the question, position A is right here, too far from the equator. Position B, too far from the equator. Position C, that looks more like it. Yeah, close to the equator. That was where New York was around the Devonian period. Definitely it's not D. It wasn't in the southern hemisphere. There goes your answer. All right, let's move on. Question number 7. And we are done with geologic history. Now we're moving on to half-life. Okay, so the question says, the graph below shows the radioactivity decay of rubidium-87, blah, blah, blah. The percentage of rubidium-87 atom that will be left after 4 half-life is, so it's asking after 4 half-life, what percentage will be left? Like we discussed during this half-life topic, when something is started, it always starts at 100%. All right. So after the first half-life, it will disintegrate. Half-life means divide by 2, right? So it will disintegrate into half. So half of 100 will become 50%, right? And then by the second half-life, 50% will be divided by 2, which will give us 25%. By the third half-life, divide by 2 again, this will give us 12.5%. And then by the fourth half-life, this should give us 6 point something something. All right, 6.25% thereabout. So I don't even need my earth science reference table for this. The answer is right there staring at me. 4 half-life. So divide by 2, divide by 2 again, divide by 2 again, and divide by 2 again. 4 times, 4 half-life. If the question is after 2 half-life, divide by 2, then divide by 2 again. If the question says 6 half-life, divide by 2, 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 and divide by 2 6 times.
Easy breezy. Let's go on. Question number 8.
All right, question number 8. Go ahead, attempt it. All right, base your answer to the following question on the graph below and on your list of earth science. The graph below shows the percentage of radioactive isotope carbon-14 and the disintegration product produced during the half-life of the radioactive decay. The main question says the disintegration product represented on the graph is, so what disintegration, all right, what disintegration product, which means when carbon-14 here and carbon-14 here, when it disintegrates, what product does it go to? So remember, radioactive elements are elements that are not stable, so they decay to become more stable. They decay to produce new products. All right, so as they decay, what products do they transform to? So what earth science reference table should I be using for this? You know what it means to disintegrate, by the way? All right, is to decay. All right, to decay or to decompose or to reduce or to become more stable. So what does carbon-14 disintegrate into? That should take us to our ESRT. I think I should write that down. So using this question, this should be ESRT page number 1. That's the table that talks about half-life of different radioactive elements. So let's go there, shall we? It takes a lot of time to scroll this guy down. Sorry. Try not to make this recordings too long.
What can I do?
Hurry up, buddy. All right, finally it has loaded. Let me be sure I'm recording. Yep, recording continues. All right, welcome back. So I got it here, radioactive decay table, page number 1, and I see carbon-14 right here. So when carbon-14 undergoes disintegration, decay, or to decompose, it reduces from carbon-14 and gives us N14, nitrogen 14. So that's the product that it gives to us. So simply put, whenever you have such a question talking about products, these are the products. These are the products. These are the products. And these guys, on the other hand, that I'm going to use the green color for right now, these guys are the unstable elements. Unstable, unstable, unstable. So those unstable guys, they decay to form the guys in red circle, which is the product. So going back to answer that question, our product for carbon-14 will be N14. So let's go back. So it's not A, definitely not B, definitely not C either. We're looking at N14. So the answer for that question is D. All right, let's move on. I don't want to exceed 30 minutes for this recording. All right, question number 9. Which igneous rock could physically weather to beach sand that contains the mineral? So I'm looking at igneous rock that can decompose to produce these minerals: pyroxene, pyroxene, feldspar, and olivine. So since it has to do with igneous rock, I'm definitely looking at my ESRT page number 6 or 7. 6. I hope I'm right. But I know it's around that area, 6 or 7. Okay. What else is the main thing in this question? So these minerals, these are minerals, these are minerals, these are minerals. That's igneous rock. Igneous rock is produced by cooling. All right. Cooling and solidification of lava or magma. Good. All right. I know my question packet is messed up already. That's why I asked you to have another one open on the side. Okay, so let's look at page number 6 of our ESRT. Boom, boom, page 4, page 5, and here we are, page number 6. So we are looking for those igneous rock that will produce those minerals that the question talked about. Okay, so I'm going to zoom in so I can have a full page. Sorry, my system is a little bit acting up with this Kami. All right, let's go back to those minerals again. I have pyroxene, pyroxene, feldspar, and olivine. All right, pyroxene, feldspar, olivine, and pyroxene. Good. So since it's all these guys together, then it has to be one of these. I wasn't talking to you. Shut up. All right. So it has to be one of these guys because these are the guys. Let me pick up my markup. I think that would help here. Or should I say the text highlighter? Box highlighter. Yeah. So because these are the guys that will have all these minerals in them. So it has to be one of those rock that will have pyroglicase feldspar and also have pyroglicase feldspar, have pyroxene, and then have a little bit of olivine. So it has to be one of those rock. Gabbro, diabase, basalt, vesicular, basalt, scoria, and basaltic glass. Okay, so let's go back to the midterm. Dunite, definitely not dunite. Why not dunite? I can't even find the rock. Dunite, where are you? Okay, dunite is right here. So dunite does not contain all these other guys. Dunite is actually monomineralic. It has only one mineral, and that is olivine. Definitely not dunite. Granite, definitely not granite. Granite is on the left side. Granite is a felsic, light color, low density, rich in silicon and aluminum kind of rock. It does not fall in that region. We are definitely looking at a basaltic rock because these are the rocks that are going to be mafic, high density, and darker in color. So it's definitely not granite. Peridotite is definitely not it as well. Peridotite, where are you? Review yourself before I kill you.
Did I just say that? Never mind. Just a joke.
Peridotite. I thought I know. Oh yeah, peridotite is right here on the corner here. All these hidden guys. Peridotite only has two minerals, and it's olivine and pyroxene. So peridotite does not have any pyroglicase feldspar. If you look at it downward using that broken line, it does not. So it's definitely not that either. So we are left with only one option, Mr. Gabbro. So you see Gabbro right here. Gabbro has all those minerals that we talked about. And that's it. Let's go to our last question. And yay, I didn't make the recording more than 30 minutes. So fair enough, fair enough. Question number 10. Question number 10 says, which graph best represents the relative density of three different types of igneous rock? Relative density. So I have three types of igneous rock here. I have rhyolite, I have andesite, then I have basalt. And we are looking at their density. Once again, you see that word relative. When you say something is relative, it means you are just comparing one thing versus another. Just like relative dating. Relative dating will say older, this is older than this is younger than this is taller than this happened first than this is more recent than this. So we are only looking at the relative. So we're not looking at the specific absolute number. That's not what we are looking at right here. We're just comparing which is older, which has more, which has less, which is taller, which is, and all this kind of stuff. So whenever you see that word relative, that's just what it simply means. So relative density of three igneous rock: rhyolite, andesite, and basalt. So we're going to use that ESROT page number 6 as well. So I have rhyolite. So rhyolite is here. What other rock? Andesite. Andesite is right here. What other rock? Basalt. Basalt is right here. Okay, this is what we know. This rock, in terms of density, give me a minute, I'm trying to change this color. Give me blue and get out of here. All right, so we know that this felsic rock, they have lower density, right? Lower density, while mafic rock have higher density. So any guy who is to the right will have a higher density. Any guy who moves closer to the left will have less density because they are felsic, lighter in color, lower in density, and contains silicon and aluminum. So the highest, the one that has the highest density here will be basalt because it's the rightmost guy. So basalt will have the highest density, followed by andesite, and then lastly rhyolite. So basalt, highest density. So we are looking for the one where basalt has the highest bar in terms of density. So it's definitely not this. Basalt's too low here. Definitely not this as well. Basalt has to be the highest. Remember, it has the highest density. Definitely not this as well. Once again, basalt has to be the highest. And yeah, here basalt is the highest, followed by andesite, right? So 1 basalt, 2 andesite, and then lastly rhyolite. So basalt, andesite, rhyolite. So our correct answer here is D. That's it, ladies and gentlemen. I wish you best of luck with your midterm next week, Wednesday on the 20th. I'm gonna do another video actually that would kind of touch on everything that we've done, sort of the ones that does not have to do with the ESRT. So be sure to check that video out as well. It's going to help you a lot. If you need any tips, remember you guys did a lot of CK12, so you want to go back and read those CK12s or watch those videos on the CK12. That would help you as well. Over time, almost every other day, we give you packets that has a lot of reading in them, a lot of practice questions on them. Now is a good time to flip through those pages again, just read and refresh your mind. And of course, these videos that me and Mr. Pierre are putting out for you guys, well, we just want to make sure you guys have all the resources and all the opportunities to read and practice and all the materials to ensure that you guys are successful in earth science. Earth science is a lot of content that we are getting through, as you can see, in a very limited time. So we're just doing our best. This is not in any way to consume your time or anything, but we just really want the best for you in this course. All right, that said, have a great day and bye.